Okay, so this is the next question that we have on the menu today, and it's asking us the terminal side of theta, which is the angle. So the terminal side of the angle in the standard position contains the point 3, 0. Okay, how do we find the exact values of each of the 6 trigonometric functions of theta? Okay, so a lot to unpack here. Let's start here. So the terminal side of theta, the angle, in standard position contains the point 3, 0. Okay, so let's draw that out and what that really means. So if we were to draw an XY coordinate grid, forgive my imperfect lines. So if that's the X and that's the Y, I mean, we don't really need to say X, or I guess we do, because you see how its coordinate is like X and Y. So it says our X position is 3, so this is 1, 2, 3. Okay, our X position is 3 and our Y position is 0. Well, I guess that just means we're on the X-axis. That means our point of interest is going to be right here. Okay? So our angle, or our thing is definitely going to be looking like this. And our angle, well, the only angle that can make this work, because we measure angle like this way, angle measurement, so the only way that this is going to work out is if it's if the angle is 0 or if the angle is 360 degrees. They pretty much will result in the same math, so it's going to be a lot easier if we just deal with this situation where we just know that the angle has to be 0. So theta equals 0 degrees must be the case if the line is straight and contains point 3, 0. 3 in the X, 0 in the, 0 in the Y, yeah. Okay, so, yeah, and that's the terminal side. So this is how we find the angle. So that's the first part of it, is identifying the angle. And then we have to find the exact values of the 6 trigonometric functions for theta. So what that means is we have to find sine of theta, cos of theta, tan of theta, cosecant theta, secant theta, and cotangent of theta. And this is, well, once we find the first 3, we've pretty much found the others, because we just flip them upside down on the reciprocals, and we can get our last 3. So we really just need to find the first 3, which is fairly straightforward. 1 over tan theta. And tan theta is just sine theta over cosine theta. So if we find the first 2, we pretty much got them all. Okay, so sine theta, when theta is equal to 0, so let's draw out what the sine graph looks like. Like this. So sine starts at 0 and it goes like this. Okay, so this is sine theta. And we know sine at 0 has to be 0. Fairly straightforward. Now for cos, cos looks a little different. It looks a little something like this. Cos theta in blue. And, well, as you can see, cos at cos when theta is equal to 0 has to be 1. Okay, so tan, if it's just the sine divided by the cos, it's just going to be 0 over 1, which is equal to 0. Fairly straightforward. Okay, cosecant is just going to be 1 over 0, but you know, you can't divide 1 by 0. Nothing can be divided by 0, so this is undefined. Secant, well, we just take the reciprocal of 1. So 1 over 1, which is equal to 1. Nice. Happy face. And the inverse of tan, well, we have to do 1 divided by 0. So that's another 1 divided by 0 case, which is undefined. Okay, so that would actually like pretty much wrap up the entire question. Yeah, once we found sine and cos, everything was good. Everything was good. Okay, so hopefully the answer that we have down here agrees with us. Yep, everything is good. So the above solution is good. Awesome. You just had to pretty much once we found the angle, everything was fairly straightforward after that. But yeah, so just find the angle, knowing the points. Of course, it didn't have to be there if it was like 3 and 4, and it was like maybe up somewhere like here. We would need to calculate that angle first, and that angle would not be 0. But if the angle's not 0, it doesn't really make our life more difficult. We just we would just send that non-zero number into our calculator, or we can do it graphically depending on how convenient the number is. But yeah, it'd be all pretty much the same procedure. Cool. So this solution is good. The above solution is good. Beautiful.